Hello friends. Today let's look at binary search algorithm. Binary search is a searching algorithm or a searching technique to find a specific item in a sorted list of items in an efficient way. To see the motivation for this algorithm, let's consider the following example. Let's say we have a bunch of playing cards in any random order placed on the table facing down. And let's say we have to find a specific card in this list of cards. The way to do that would be flip the cards one by one and see if we find the card we are looking for. We will have to flip over the cards one by one, and we can see that in the worst case, if the card we are looking for was the last card in the list, we would have to flip over all the cards till we reach the end. This is called linear search. So, in general, to search an element in a list using linear search, each item in the list is compared with the target one by one as seen in this example. This search is performed until the target is found or until the whole list is searched. We can see that in this approach, for the worst case, we will have to keep searching till the last element in the list, resulting in a maximum of n comparisons for a list of size n. And this doesn't look too bad for a small list. But if we have a very large list, this approach will be slow, especially for the worst case scenario. So now let's look at a sorted list instead. Can we get a better solution if we have a sorted list? We can always use linear search in a sorted list as well. But we can also have a better algorithm which will be faster called binary search. Now let's look at binary search. Let's consider the same example of cards again, but this time these cards will be placed in a sorted order. Let's say we want to find this card having 4 in this list of cards. This may or may not be present in the list of cards. Let's see how binary search works for this example. In binary search, we find the middle element first and compare it with the target. So in this case, the middle card is flipped over and we find that it has number 6 and our target is 4. So when we compare the middle card with the target, we see that the target is less than the middle, so it has to come before the middle card. It cannot be present in any of the cards that come after the middle. So we need not search in any of these cards and we can discard these cards here. For the next iteration, we will only have these first 3 cards and we will perform the same steps. We will turn over the middle card again. This time it has number 3 and our target is greater than the middle. So we need not look at any of the cards that come before 3 and we can eliminate the first 2 cards this time. Now we are left only with the last card, and when we flip that over, we find that we get a match and find our target, which is number 4. So we saw that in binary search, since we eliminated half the list at each step, we reduced the number of comparisons. Even in the worst case, the total number of comparisons needed are much less than what we saw in the linear search approach. So, in summary, binary search works by dividing the list of items in two halves repeatedly and discard the half at each step that will not have the target for sure. This results in lesser number of comparisons than what we saw in linear search, and hence we got a better time complexity. So that's it for today's video. Thanks a lot for watching.